I'm more interested in athletic performance and tracking for that. So I climb and do a lot of other very weight-dependent sports. So kind of optimizing strength to weight ratio is the basis of why we're tracking data. So just a quick summary of some of those things that I've been doing.
It's a little bit quiet.
Oh, sorry.
Is that still quiet as well?
Is that better?
Yes.
Okay, sorry. So for about maybe 2 years, I've been tracking weight, both with a scale that I built by hand and commercially available living scale, and food intake using fat sinkers because I have an open API. And I've done some experiments with that. Along the way, in order to visualize what I've been tracking, I've been pulling together stuff from Python. And here is Pandas, which is kind of similar to R. And actually visualizing it with Matplotlib and D3, which are different graphics frameworks. And got some other stuff at the end that's kind of borderline quantified self, more like real-time feedback of certain sports skills that I'm going to show up. So the weight tracking, when I first started out, it was before Withings and Fitbit had put out their own commercial scales. So I basically decided to build them from scratch. I don't know if there's anybody here that's interested in hardware, but very quickly, 24 beta D, which surprisingly, even though I put together by hand, got decent resolution. I did the Bluetooth integration myself, and did some little power switching tricks to make sure that this actually run for a decent amount of time on instead of 4 AA's. And this is the lovely scale itself. As you can see, it's actually an IKEA scale with all the electronics stripped out, except for the strain gauges. So in each of the 4 corners, those little circles are actually 4 different strain gauges, and they're all being fed into multi-channel A to D, and I'm basically doing some fancy math there to even out all the very noisy readings I'm getting, since this is not on an actual PCB. This is just hand soldered surface mount components, and somehow I'm getting like 60 bits of resolution off that, which amazed me. But a little bit of a close-up, you can see the lovely wiring job there. That's a Bluetooth module, power regulation, and on the other side of that is the A to D with very, very fancy wiring here and hand labels. So a little bit more, why bother tracking weight rather than just using a scale that has a visible LCD on it, like most scales. And actually, I intentionally did not put an LCD on that scale so that I wouldn't think about it every day, like, oh, it changed by 0.2 pounds from one day to the next. I decided that looking at long-term trends was more useful. And kind of an interesting thing that I found out is that even if I wasn't intentionally trying to change anything, just the mere act of tracking weight and knowing that I had the data inadvertently caused me to change my behavior. So it's kind of a little psychological trick where seeing the data in front of you makes you just kind of subconsciously eat less, which is kind of an interesting thing. And conversely, when I stopped tracking, as you'll see later, my weight just kind of ramped up just because I didn't have the data in front of me anymore. So that's basically what I'm alluding to here, is you'll see, is that visible there? When I first built the scale, I was really good about tracking. That's that little cluster where I've got very fine sets of data, and then I stopped tracking. And you can see that once I stopped tracking, my weight just kind of went right back up. I got lazy, basically. But part of that also points out that the friction in quantified self-step is really important, because at the time I had a crappy, like a Droid 1, and just logging data was very, very slow. So that's part of the problem, where I just got too lazy because it took too long to enter food data and calorie data, and I just gave up. So that's part of what I've been working towards, is making this as friction-free as possible, where the data entry just takes like 5 seconds, and the weight stuff is done automatically. And again, why I didn't add a display on the scale was found it to be more useful to just periodically, maybe once a week, look back at data points. And as you can see, it's really noisy because for any given person, the amount of variance in a single day for weight can be like 5 pounds. But if you look at it over the long term, you can see that starting in April, that's actually when I started intermittent fasting and running every day. From then until now, there's a clear trend, but on any given week, it would look like nothing's happening or I'm getting worse. So broader visualization is more useful than just instantaneously looking at a display is what I found. So again, this is many, many months, but if I zoom in on May in particular, it looks flat. It looks like it's not going anywhere. And this was actually during a little experiment where I was trying to see, it doesn't matter when during the day you eat, you know, the myth of if you eat at night, you'll get heavier. Doesn't seem to be true, at least in my case, over the span of 4 weeks or so. And this graph in particular is done with D3, with, you know, pretty colors compared to the previous one. A little bit more on some tools. So the same way that I did the D3 and the Matplotlib stuff was using a Python library called Pandas, which is done by Wes McKinney. It basically does very nice time series analysis, makes it very easy to use, and it handles very nicely sparse data. So if I have weight data that's sampled every day, and I have food intake data that I got lazy about, and I only have entries for once a week, I can align them and then plot on top of each other without having to manually reconcile the fact that they're not equal one. So that's handy, and it made this visualization stuff easy since I did it, you know, today. Matplotlib is what was done for the blue plots, like this one and this one. And it's very, very easy to use. Like it's, you know, maybe 5 lines to each of those previous plots. And the rolling average that's done here, this trace that goes on top of the noisy line, that's done with Pandas that has rolling window functions. So you can do standard deviations, means, medians, things like that. And D3 is very nice for interactive visualizations. Unfortunately, I didn't have time to make one that's interactive, but I do have like something I use at home that's like this plot, but if you mouse over data points, it'll give you a little tooltip that shows what the exact values are there. And, I actually have a daily photo database that's pulled off of Flickr, and it'll bring that up and other information on each data point. So D3 is nice like that, but I did not have enough time to hack something together for today. And there's some other stuff that I'm not showing today because, again, not enough time, but I have code for, besides Withings and FatSecret, I also have code for Fitbit, Instagram, Flickr, and a couple others. But I see there's a guy here from Singlets, so I'm tempted to look at their stuff. And I've been using filepicker.io for some other stuff, so I definitely want to check out Singlets eventually. The stuff that I have done so far, and it's actually in somewhat usable shape, it's up on my GitHub here, if anyone is into Python stuff. I know I'm kind of racing along here. And let's see. One last thing, which is only tenuously related to quantified self stuff, is more like an instantaneous feedback kind of thing. For gymnastics timing, I basically made a brake beam sensor that works at long range. So let's see if I can, hopefully this will work without. Can you see my cursor here?
You must have copy and pasted this far.
Yeah. Well, actually, it's not that exciting to see. It's really just, if you can see on the right where my cursor is here, as you swing past the vertical line and you break the beam between the two sides of that, it'll give you just an audible feedback of where you are. So when you're doing giant swings in gymnastics, you want to hold a certain position until you reach the bottom of the swing. And without feedback, you tend to basically stay arched late. And this was a way to correct that. And over a span of about maybe 2 weeks, just that little audible feedback dramatically improved the technique. So I've also been using, besides kind of photo feedback, I've been using video feedback, and then I have YouTube playlists for each day as the skill gets better. And I have a tool to do that.
So you're at about 9 minutes.
Oh, sorry about that.
I'm using this, so I feel a bit rude. Like,
oh, no worries.
Yeah.
Thanks.
So you got 3 minutes to have questions. Yeah. So we have 3 minutes now for questions. Go ahead.
I was fascinated when you talked about how it seemed easier not to have the number on the scale. And I was wondering, when you got the Y things, did you cover it up, or did you notice, and also did you notice a difference, like emotionally, how easy it was to do the research when you weren't looking at it every day, and were you getting different kinds of results from like separating your attention of daily awareness to more like a weekly awareness?
Well, when I first bought the living scale and got turned off my home built one, I left the display visible for a while, and I noticed that I was getting a lot more frustrated because just in a single day you might jump by like 3 pounds and think, oh, I'm doing something wrong. So I did eventually end up just covering it up, and I just look at the Python data now. So yeah, psychologically at least, it does have an impact. Because even though you know it doesn't matter, when you see it, you think, oh, well, something's wrong. So,
Thank you.
anybody else?
On a similar note, like, what did you talked about a lot of experiments you ran. Do you have any kind of conclusive results for the things that you learned? Like you mentioned, like the myth of eating late isn't really true. But so, what did you find that was a myth and what was not?
So I did a couple other things like holding the same caloric intake. Does intermittent fasting in and of itself do anything to weight? And the answer was no. And is it really as simple as calories in, calories out? And it seems like yes, because in that one plot where it suddenly starts tracking downward here, that's actually because I started running every day while holding basically the same calorie intake. So just kind of verifying basic math that raise your output, then it's definitely going to change your weight, things like that. So I did meal timing, intermittent fasting, and I'm trying another one I'm just starting right now, which is while holding the same calorie intake, just shifting carb intake on the days when I have choice daily training to see if that improves subjective performance. So that's not done yet.
Do you think you could do something similar with like body composition as opposed to weight?
Yes, and actually I didn't have time to add that, but so there's a handheld tool called the Body Metrics Ultrasound. It's basically a fat measurement tool, and that's the only one where I think that would be viable because the kind of fat measurement you get at a scale, the bioimpedance, the quality of it is terrible. And DEXA, you definitely don't want to do ionizing radiation on a regular basis. Hydrostatic dunking you can do, but it's expensive and you can't do it every day. But this ultrasound thing I did use, and I've actually reverse engineered the protocol for it so I can pull the data out of it, but it does cost like $600. A friend of mine bought it for a business to do study. So, but it's basically a little handheld thing. You put down gel on like a few measurement points and it gives you like 5.3% or whatever your value is. You can plot it over time. So I have DEXA data, but I didn't have time to put it on here. I have hydrostatic data too.
We're pretty much out of time. So there you go. One more round of applause.